Hi everybody, welcome to another video in Math 1332, section 11.1, the fundamental of counting principle. So, this is also called the multiplication rule. So in the sequence of n procedures, if the first task can be done in k1 ways, and the second task in k2 ways, and the third in k3 ways, and so on, then the total number of ways the sequence procedure can occur is k1 times k2 times k3 times kn. For example, if this guy wants to choose an outfit, 2 different pants and 3 different shirts, and then 2 different pair of shoes, so he can have 2 pants, and for each one of them corresponding there are 3 shirts, and for each type of shirt there are 2 pair of shoes. So together we have 2 pairs of jeans, 3 shirts, and 2 pairs of sneakers. All together there are 12 different ways of choosing an outfit. So right, easy, right? 2 times 3 times 2. Right, next we have this example. A discount pen manufacturer plans to make several different pens. The categories include this: what kind of pen, how many kind of pen can be made. So first color, 1, 2, 3, 4, 5, 6, 7. There's 7 colors. Type, there are 2 types. Latex, alloy. Texture, flat, semi-gloss, and high gloss. There are 3 types. And then the use 2, indoor and outdoor. So all together we can choose, just going to write like this. For color, there's 7 different types, 7 different colors, 7 options for colors. For type, can choose 2 different types. The texture 3, and the use 2, and multiply all of that together. 7 times 2 times 3 times 2. So 2 times 2 is 4 times 3, 12 times 7, that will be 84. So there will be 84 different kind of pens. Right, just like that. Right, next, the lock on the storage facility is controlled by the keypad, contain 3 digits from 1 to 5. How many 3-digit codes are possible if the digits can be repeated? So there are 3 digits. And we can go from 1 to 5, so there are 5 options. And this number can be repeated. So that's 5 times 5 times 5. 5 for the first number, 5 for the second number, and 5 options for the last one. So that total 125 different ways up to choose the codes. Now, how many 3-digit codes are possible if the digits cannot be repeated? If it cannot be repeated, the first number there's 5 choices, but the second number we cannot repeat the first one, so there's only 4. And the next number cannot be repeated as the first 2, so there's only 3 options left. In total we have 120 options of choosing. So this fundamental counting principle, or the multiplication rule, we just write different stage, and this stage we list how many options we can carry out that task for that stage, and then at the end multiply everything together. Pretty much like just that. Right, next. The Greasy Spoon restaurant offers 6 appetizers and 14 main course. And there's 6 appetizer and then 14 main course. And how many ways we can choose the 2-course meal? Just 6 times 14. So 6, 4 is 4, okay, 2, so 84. So that's the 84 option. Right. Next. Telephone numbers in United States begin with 3-digit area codes, followed by the 7-digit local telephone numbers. The area code and a local telephone number cannot begin with 0 or 1. How many different telephone numbers are possible? Right, so the problem is very simple. I just want to discuss a nice fact about this. Right, so we know that the area code of Dallas is 214, right? And I bet if you look for something like the 213, the smaller the number is, it tends to be from the bigger city. Because the older age of telephone, you have to dial. So the big city, they want to make a smaller number. So when to dial, the time when you make a dial, it's quicker way to make a call, right? So for example, 2 instead of 9, you have to make almost the whole revolution. So in that case, we choose a smaller number. So you can look up the area code of Dallas, New York, Chicago, LA, all the big city. The area code tend to be smaller, right? And but right now we just hit the button, so it doesn't matter the numbers. Right, so I got that interesting too fact about things. Anyway, so we have the area code, 3 digits, do not start from 0 or 1. So this is the area code. And followed by 7. Right. So for area code, we cannot start from 0, we cannot start from 1. So there's only 8 digits left. 2, 3, 4, 5, 6, 7, 8, 9. But the second digit can be anything. At 10 and 10. Right. And now the telephone number. And cannot start from 0 or 1. So again, there's A option. And everything else is 10. So when we multiply all of this together, multiply everything, this is a dash, not subtract. So we have there 2 A's and 1, 2, 3, 4, 5, 6, 7, 7, 10. So A squared 64, and that's 7, 0, 2, 3, 4, 5, 6, 7. Right, so that's about 64,000, 640 million possible phone numbers. Right, so we have about 300, let's say 360 million people in the US. So that's more than enough for one number for each person. But of course, remember, this is not only for US, it's also Canada using the same system as well. But that's how many we have here. Right. Oh, sorry, I missed 1. 1, 2, 3, 4, 5, 6, 7, 8. Right, so that means, sorry, we have 6,400,000,000. So that a lot more than, so pretty much enough for one person can have 10 different numbers or more than that, right? So 1 2 3 4 5 6 7 8, so 10 to the 8, so then a0 a squared 64, so that's what we have. So about 6 billion something, so that's more than enough for everybody. Right, with that we finish the first section in this chapter, section 11.1. As always, thank you for watching. See you in another video in Math 1332.